We often think of apex predators as cold, efficient, almost mechanical killing machines. We assume nature's rules are absolute, right? Predators hunt, prey runs, and species boundaries are these unbreakable walls built over millions of years of evolution. But what happens when those rules completely break down? Welcome to This Explainer. Today, we're diving deep into a truly fascinating biological mystery. We're going to focus on what happens when neurobiological software vulnerabilities, literal glitches in nature's coding, cause these astonishing anomalies where predators actually protect their prey and completely different species become family.
To understand how completely different brain circuits fire to override raw biology, we've broken this investigation down into 5 key areas. 1. The predator's software glitch. 2. When rivals become family. 3. Crossing the evolutionary gap. 4. The power of distress calls. And finally, 5. The biology of compassion.
Section 1. The predator's software glitch, or when predators protect their prey. Okay, let's dive right into this first one to examine what is basically the ultimate biological paradox: animals making the active, conscious choice not to eat their natural food source.
Our first case completely stunned researchers back in 2001. Picture this: you're in Kenya's Simbu National Reserve, and there's a young, healthy, and incredibly hungry lioness named Kamunyak. She absolutely should have been hunting, but instead, she was found sleeping beside a 2-day-old oryx calf, literally positioning herself between it and the rest of the world. Now, the oryx is precisely the animal she was built to eat. It was this unbelievable moment where a predator looked at something it was supposed to kill and made a completely different decision.
And get this, it wasn't just a one-time fluke. Staggeringly, across 3 years, Kamunyak adopted 6 successive oryx calves. 6! She fought off cheetahs, hyenas, and even members of her own pride to protect them. She walked past viable prey every single day in her 15-square-mile territory just to guard her natural food. A completely different circuit in her brain fired, and nature apparently had absolutely nothing to say about it.
But this software glitch doesn't just happen on the savannah. It manifests up in the sky, too. Up in British Columbia, a bald eagle, which is one of the most effective aerial predators in North America, dropped a 2-pound red-tailed hawk into a nest of 12-pound eaglets. Under normal circumstances, that hawk is lunch, for sure. But instead, the incredible happened. The hawk woke up, started begging, and the eagle just started feeding it.
The reason why this happens lies in a specific neural circuit. It's a neurological pathway that, in adult raptors, triggers an immediate feeding response to an open, begging mouth, totally regardless of the species. The very neural circuit that gives the eagle its deadly lock-on predatory response has a profound glitch. If a juvenile begs like a chick, the adult feeds it. That ruthless killer instinct doesn't verify species. It doesn't check ID. The hawk successfully fledged from the nest, proving that an open mouth is pretty much the ultimate vulnerability in a predator's software.
Section 2. When rivals become family, overriding deep competition. Let's move to the next section and see how this builds when the boundaries between fierce ecological competitors just completely dissolve.
Check out these 2 incredibly distinct cases. First, in 2018, over in India's Gir National Forest, an Asiatic lioness was documented grooming and nursing a 2-month-old leopard cub right alongside her own cubs. Now, lions and leopards are direct competitors that fight for territory. That cub should have smelled like an enemy, but the lioness completely overrode that competitive species signal. And similarly, down in a Brazilian woodland, a group of capuchin monkeys, who are actually documented predators of marmosets, spent months carrying around a common marmoset, essentially raising their natural prey.
Honestly, the visual absurdity of this adoption is just mind-bending. The marmoset completely lost its own species reference points. It's the biological equivalent of a chihuahua carrying around a golden retriever puppy that it was supposed to eat. A hungry capuchin group will definitely eat a marmoset, but a satiated one apparently decides the line between dinner and family isn't fixed at all.
Section 3. Crossing the evolutionary gap, bridging millions of years. We're now going to look at marine mammals who break entirely different biological rules, crossing vast stretches of time, space, and genetics.
And this brilliantly illustrates the sheer evolutionary distance that can actually be breached. Over in French Polynesia, a bottlenose dolphin named Tai was flooded with oxytocin after a recent birth, and she simply picked up an orphan melon-headed whale, a species with totally different vocalizations and body shapes. It's roughly what it would look like if you found a stray kid at the mall and just decided to keep him. Meanwhile, in the St. Lawrence River, a narwhal traveled 1,000 miles south of its Arctic range to join a bachelor pod of belugas. These species diverged 5 million years ago and speak completely different acoustic languages.
I mean, imagine a polar tourist showing up to the wrong family reunion and just never leaving. Despite having a massive 9-foot tusk, which, by the way, is definitely not standard beluga equipment, the narwhal swam in formation and played right alongside them. He was accepted as one of the boys for 3 straight years, completely bridging a 5-million-year gap.
And off the coast of Iceland in 2021, an apex predator took this to a whole other level. An orca named Sedatus was observed utilizing this highly specific maternal posture called the echelon position to carry and protect a long-finned pilot whale. Here's the kicker. Orcas actively hunt pilot whales. Yet Sedatus was using a behavioral wiring designed for intense social bonding to save the energy of the exact species she would normally hunt.
Section 4. The power of distress calls and acoustic triggers. Next up, let's explore how desperate acoustic signals can actually trigger attachment circuitry across huge distances, long before a visual species check even happens.
Just consider the sheer difference in scale between these two animals for a second. In 2022, off Western Australia, a 250-ton adult southern right whale was documented swimming in sustained maternal body contact with a juvenile humpback calf. These whales do not travel together. Their migration corridors do not overlap at all. From above, the humpback calf reads as a tiny little decorative element beside the massive right whale. It was an absolute biological anomaly.
So how on earth did it happen? Well, a southern right whale's low-frequency hearing can span 50 miles of open ocean. The leading hypothesis is that this bereaved right whale, who was in a searching state, heard a distress-calling humpback calf from miles away. Whatever she heard in that call felt like an answer. The acoustic trigger hit her maternal circuitry, and her biology responded before her eyes could even confirm what species she was saving.
And we see this acoustic override play out in the Amazon canopy too. Look at these two competing primates. A lone 1-pound howler monkey infant makes an extremely loud noise when in distress, which normally just attracts predators. But on one afternoon, that distress call cut right across species lines. A female spider monkey heard it, rushed over, picked up the infant, and sprinted with it 60 feet in the air through the canopy. They've competed for the same fruit for tens of millions of years, but the sound of a baby in trouble overrode all of it.
Section 5. The biology of compassion, or the vulnerability override. In this final section, we uncover the climax of our scientific mystery, the actual neurobiology of why this happens.
The events of an incredible night in Botswana's Okavango Delta mapped out exactly how this happens. Legodima, a hungry young leopard, hunted and killed a baboon. But the baboon had a 1-day-old infant clinging to it. Instead of eating the newborn, Legodima pulled it from its mother, carried it up into a tree, and spent the entire night grooming it and moving it to safety whenever hyenas approached.
And this brings us to the actual science of the software glitch: infant release signals. We tend to think of predators as emotionally blank, right? But the very brain architecture that makes them so brutally effective is actually built upon deeply embedded social bonding and attachment circuitry. The visual and auditory cues of pure, helpless vulnerability act as a massive inhibitor.
Legodima literally abandoned a fresh, dead meal on the ground to protect an infant that could offer her absolutely nothing in return. Every circuit in her brain should have told her that infant was food. But encountering something so helpless hit a completely different biological switch. This isn't a metaphor, guys. It is the ultimate software glitch.
Which leaves us with this final, massive thought. We have spent 50 years studying this phenomenon, and we still haven't fully explained this miraculous vulnerability. If the deadliest animals on Earth can look at their natural prey, ignore millions of years of survival instinct, and choose to nurture them instead, it fundamentally challenges everything we assume about animal consciousness. It makes you wonder, what else is nature capable of that we just haven't seen yet? Thank you so much for exploring this with me today.